Okay, let's continue. And the next topic is the logical operators. And for the logical operators, we have a total of three: and, or, and not. Well, and let's say we have x and y as two Boolean expressions, and then we can use and or to connect two Boolean expressions. We can do x and y, or x or y. And then for the not, and it is a unary operator, so we can do not x. That is to flip a true into false, or to flip a false into true. So not is the easiest. So that is true if not is the easiest, because true if it is false, we flip it to true, or if it is true, we flip that into false. And for the and, the rule is we will get a true if and only if both of the operands x and y are true. So we will only get a true if that is a true and true. Otherwise, for false and false, false and true, or true and false, they will all be evaluated into a false. Okay? And for the or, x or y will give you a true if either of the operands, either x or y, is a true. So true or true gives you a true. True or false, false or true also give you true. Only false or false will give you false. Well, it's really hard to talk about that. Let me just show you the truth table. So for the truth table, now we are using P and Q, okay? So P and Q will give you a true only when true and true. And for the rest of the three cells, true and false, false and true, and false and false, they will all be false. Let me just fill them in. So false, false, and false. And how about the next one? And that is P or Q. So true or true will give you true. And then how about true or false? That's it, true. False or true? True. False or false will give you false. Okay? And then how about the next one? So true, and then if you want to do a not, P and then not P will give, if P is true and then not P will be false. And then if P is false and not P will be a true, right? Okay, so this is how to fill in the truth table, but I'm gonna revert everything, and this is the version I'm gonna give you. And then you need to know how to fill in this table by yourself, okay? Okay, let's see some of the exercises. So if, print 5 greater than 3 and 5 smaller than 7. That will give us a true. Why? Because there are two operands, 5 greater than 3, that is a true. And then 5 smaller than 7, that's also a true. So we have a true and true. So that is indeed a true. And how about the second one? 5 greater than 12 or 5 smaller than 8. So the first operand, 5 greater than 12, that is a false. And then 5 smaller than 8, that is a true. So false or true. For the or operator, as long as we have one true, that is a true. So the second one is also a true. And the third one is a little bit harder. 3 smaller than 5 and not 2 greater than 7. So for the first operand, 3 smaller than 5, that is a true, no problem. And then 2 greater than 7 give you a false. And then not false will give you a true again. So that is true and not false. That equals to true and true. So that is also a true. But this does raise another question. We have and a not. Which one should be processed the first? And the answer seems to be not, right? Because we are gonna flip a false, not false, into a true first before we process or before we take the AND operator. So what does this remind you? Operator precedence, right? So we have to talk about operator precedence again in the next exercise, okay? And let's continue with one more exercise. So what's the correct Python expression for checking to see whether a number is between 0 and 5? So we have a variable x, and then how do we evaluate x and see if x is between 0 and 5? How about a? X greater than 0 and smaller than 5. So do you like the A? A sounds correct, right? So, well, how about we try that? Say x equals 3, and then print x greater than 0 and smaller than 5. It seems that Python doesn't like that, right? I removed the space. Python still doesn't like that. Why? Okay, well, if you want to go a few slides back, and then what did we talk about? We talked about this one, Boolean expression. So for the Boolean expression, that is the expression can be evaluated as a Boolean value, right? And then later we talk about the x and y, and then we are saying for both x and y, for example here, x, y, they should both be Boolean expressions. So if we take x alone or we take y alone, they should both be evaluated as a Boolean. And then what's the problem here? So for this part, x greater than 0, can that be evaluated as a Boolean? The answer is yes, right? And how about the second part? Smaller than 5. Is that a Boolean expression? No. How to make it a Boolean expression? We have to add the x here. Okay? So x greater than 0 and x smaller than 5, and then this syntax itself is correct. And if you run this, and you will see that it is true here. Okay? So let me come back to the question. The question here is A looks correct, and if you read that in English, it sounds correct. But why Python doesn't like that? Because the second part, smaller than 5, that is not a Boolean expression, right? So C is correct. And in Python, we also have another syntax, which is D. So 0 smaller than x and smaller than 5, that is also supported in Python. And well, I would say Python is very cool with the last version, which is D. So C is correct and D is also correct. And for the D, and this is kind of special in Python because say if you want to do C++ or Java, you may not have that. Okay, so I'm gonna stop the video from here and oops, wait, I should. Well, there's one more lecture, one more slide to go. That is the operator precedence. So, well, we have talked about the operator precedence of the arithmetic operators. And now we also have the relational operators or comparison operators. And even further down, we also have logical operators. Okay, so this is a full sequence or full table of the operator precedence. So here is another question. So 5 multiplied by 3 is greater than 10 and 4 plus 6 equals 11. And how do we evaluate this? Super long, right? Well, if you want to just follow the operator precedence table, and then what is the operator we want to handle first? That is the multiplication, right? So 5 multiplied by 3, that is 15. So 5 multiplied by 3 will be replaced by 15. That's the first step. And then after handling this 15, which is the next operator? The next operator is the addition. So 4 plus 6 equals 11. Okay, so that will 4 plus 6 will be 10. Okay, and then after we handle the multiplication and the addition, what's next? The next is for the relational operators or comparison operators. So greater than and equals. So 15 greater than 10, that is true, and then 10 equals 11, that's a false. So what do we have? We have a true and a false, and then eventually we only have the and as the last operator. So true and false will give you a false. So this is the process to evaluate a long expression with arithmetic operators and then comparison operators and logical operators. So that is how we can use the knowledge of operator precedence to evaluate a long and complicated expression. Okay, so I'm going to pause here and I will see you in the next video.